So we're starting our short little unit about factoring, and we're going to start with factoring with a GCF, or a greatest common factor. That is pretty much the first step in factoring. So greatest common factor is the term that goes into each term, and you're looking for greatest, like that's important. There are often multiple things that go into something, but we're looking for the greatest common factor. The word factor can be used either as a noun or as a verb. So a factor, as in terms of a noun, can be a number or a polynomial that can multiply to give you another polynomial. You're used to factors of numbers, like the factors of 6 are 1, 2, 3, and 6. But now we're going to be looking at polynomials, but they are things that multiply to give you another polynomial. The process of factoring is to find those factors and rewrite your polynomial as the product of factors. So today we're looking at GCF only, and we will get into more complicated factoring problems, but this is just the start of it. So you're going to look at each term, and you're going to see are they all divisible by a number? So if you look at 6, 12, and 3, 3 goes into all of them. So 3 is definitely part of the GCF. But there also might be a variable. So I can see an x squared and an x, so I always ask myself, do they all have an x? And since the answer is no, then x will not be part of the GCF. So to factor, you're going to divide everything by 3. That GCF will be part of the factored form. It will always be written in the front. So 6 divided by 3 is 2. The x squared will remain x squared because you did not divide it by any x's. Negative 12 divided by 3 is negative 4. The x remains the same. And then 3 divided by 3 is 1. So factored form is 3, the original GCF, and then 2x squared minus 4x plus 1. So each of these right here, the things I'm multiplying, 3, the greatest common factor, is obviously a factor. And then that trinomial inside of the parentheses, all of this is another factor as well. And in the upcoming days, we'll look and see, can you factor it even more? And sometimes you will be able to, and other times you will not. All right, so the next one, we've got negative 80z cubed plus 100z squared plus 120z. And if you're good with factors, this is going to be an easier process for you, whereas if you don't know your multiplication facts, this might be a little bit more tricky. So when you're looking at that, you might first think 2, and 2 definitely goes into all of them, but it is not the greatest common factor. So then you might think 5, and 5 definitely goes into all of them, not the greatest common factor. Maybe even think 10. 10's bigger, still not the greatest. Your biggest is going to be 20. And as a kind of piece of advice for what's upcoming, I would suggest that if your first term is negative, that you make your GCF negative as well. You'll see why when we get to it. It may not make sense why now, but we will. So then we need to look, do they all have at least one z? Yes, they do. So we know at least z is part of the GCF. Do they all have at least a z squared? And no, they do not, because this last term just has a single z. So all we can take out is a z. I can't take out more z's than what we have. So z is the greatest amount that they have in common. It's not the greatest amount of z's total, but it is the greatest that they have in common. So I'm going to divide everything by negative 20z. So you're going to divide the numbers like normal. Don't forget that your GCF is going to sit in front. So negative 80 divided by negative 20 is 4. And then when you divide with variables and exponents, you subtract the exponents. Think of it as you have 3 z's up top and you're taking 1 away. So that is going to leave you with z squared because there's 3 up top and only 1 in the bottom. For the next one, 100 divided by negative 20 is negative 5. I've got 2 z's up top and I'm going to take 1 away. So that's going to leave me with a z. And then on that last term, 120 divided by negative 20 is negative 6, and I have a z up top, and I'm taking a z away, so there will be no z's remaining. So your factored form is negative 20z times 4z squared minus 5z minus 6. So you have two factors. Negative 20z is a factor. That's your greatest common factor. And then you have this trinomial right here. And again, in the upcoming days, we're going to look at that trinomial and see if we can do more to it. All right, so now let's look at 2b to the fourth minus 6b cubed plus 4b squared. All right, so in terms of numbers 2, 6, and 4, those are all divisible by 2, so 2 will be part of our GCF. Now let's look at the b's. Do they all have at least one b? Yes, they do. Do they all have at least b squared? Yes, they do. Do they all have at least b cubed? No, they don't, because that last one right there is just b squared, so I cannot take more than b squared out of all of them. So my GCF is 2b squared. I'm going to divide every term by 2b squared. And when you write your factored form, make sure your 2b squared is part of it. So 2 divided by 2 is 1, which I don't really need to write. I'll write it and then I'll get rid of it in a minute. I've got b to the fourth up top. I'm dividing by b squared, so I'm essentially taking 2 away from 4, so that's going to leave me with b squared. So I don't need to write 1b squared, just writing b squared is good. Then I've got negative 6 divided by 2, which is negative 3. I've got b cubed up top, and I'm taking b squared away, so I've got 3, I'm taking 2 away. That's just going to leave me with a single b. And then we have 4 divided by 2, which is 2. I've got b squared up top, and I'm taking b squared away, so there will be no b's remaining. So my factored form, 2b squared, is one of my factors, and my other factor is b squared minus 3b plus 2. Again, we will go further in the upcoming days. All right, so for example 4, let's start with our numbers, 25, negative 15, and 10. 5 goes into all of those, so 5 is part of our GCF. Then let's look at the x's. Do they all have an x? Yep, they do. So x is definitely a part of my GCF. Do they all have an x squared? No, they don't. So x is the most I can take out of it. Then look at y. Do they all have a y? Yes, they do. Do they all have a y squared? No, they don't. So the most I can take is 5xy. So GCF goes in front. 25 divided by 5 is 5. I have an x squared. I'm taking 1 away. That's going to leave me with a single x. I have a y, and I'm taking a y away. The y's are gone. Negative 15 divided by 5 is negative 3. I've got an x. I'm taking an x away, so no more x's. I've got a y. I'm taking a y away. No more y's. 10 divided by 5 is 2. I've got an x, I'm taking an x away, no more x's. I've got a y squared and I'm taking 1 away. There will be a single y left. And so your factored form, 5xy times 5x minus 3 plus 2y. Those are your two factors. Okay, so I factored, that was the process. That's when I took the 5xy out, and then factored form is multiplying these two factors. So make sure, and we're going to use the word factor a lot, make sure you know the differences and what it looks like as a noun versus a verb. All right, so for this one, we've got negative 6, 15, and 3. So when we're looking at a GCF, 3 goes into all of those. Because that first term is negative, I'm going to make it a negative 3. Then we're going to look at the m's. Do they all have an m? Yes, they do. Do they all have at least m squared? Yes, they do. Do they all have at least m cubed? No, they don't, because that first term only has an m squared. So the most I can take out is m squared. Then look at the n's. Do they all have an n? Yes. Do they all have at least n squared? No. So the most I can take out is just an n. So I'm going to divide everything by my GCF, negative 3m squared n. This one's a little bit of a tongue twister. All right, write that GCF in front. -6 divided by -3 is 2. I have an m squared in the top. I'm taking an m squared away, so I will have no m's. I have an n up top. I'm taking an n away. The n's are gone as well, so it's just 2. 15 divided by -3 is -5. I have an m cubed up top, so 3 m's up top, and I'm going to take 2 away. That's going to leave me with just a single m. I have an n squared up top, and I'm going to take 1 away, so that leaves me with a single n. 3 divided by -3 is -1. M to the 4th, take away m squared, will be m squared. 4 minus 2 is 2. And then n cubed, 3 n's, take away 1 is n squared. The only thing I wrote there that I don't need is that 1 sitting in front of the m squared. So your factored form is -3 n squared. That's one of my factors, the greatest common factor. And then the other factor is 2 minus 5mn minus m squared n squared. Factored form, each of those things that I just highlighted are the factors. And final problem, 32uv cubed minus 56u squared v fourth minus 40u cubed v to the 5th. All right, looking at the numbers, you might think 2 goes into all of them, and it does, not the greatest. 4 goes into all of them, it does, not the greatest. 6 does not go into all of them, but 8 does, so 8 is part of our GCF. Do they all have a u? Yes, they do. Do they all have a u squared? No, they don't, so u is the most you can take out. Do they all have a v? Yes. Do they all have at least v squared? Yes. Do they all have at least v cubed? Yes. Do they all have at least v to the 4th? No. The most they have in common is 3. So 8u v cubed is our GCF. So that is what we are going to divide everything by. So 32 divided by 8 is 4. If I have a u in the top and I'm taking a u away, I will have no more u's. If I have a v cubed up top and I take a v cubed away, I will have no more v's. -56 divided by 8 is -7. I've got a u squared up top and I'm going to take 1 away, so that's going to leave me with a single u. I've got a v to the 4th up top and I'm going to take 3 away, so I'm going to be left with just a v. And then finally, -40 divided by 8 is -5. U cubed over u is going to be u squared because I have 3 and I'm taking 1 away. And then v to the 5th over v cubed will also be v squared because I have 5 and I'm taking 3 away. So my factored form, I've got 8uv cubed as one factor, and then my other factor is 4 minus 7uv minus 5u squared v squared. Most of the time when we're going to be factoring, you will be just factoring out a single number. But it is important to know how to take a GCF out that is more than just a number, where there's variables in common as well, because you will use that moving forward in Algebra 2.